Hello and welcome back to a new video on the Ludwig Fusel channel. Today we're going to continue on our journey into C and C++. Currently still stuck at C, but I'm going to promise you it's not going to last very long. We're going to switch to C++ soon. So yeah, let's take a look at what we got last video. Last video we made it able to specify the path to the INI that we want to parse and a optional log file, and according to this data we loaded dynamically the INI file that we desired to load. We dynamically checked if we needed logging or not. If we didn't need it logging, we don't produce a log file. If the user specifies a file, we're going to customly write to his file that he requested. So that was all good, but there was one issue that I pointed up in the end of the last video, which I want to solve as soon as possible, and actually today. So what is the issue? Well, the issue is that our INI parser should be as static as possible. So the INI parser itself should not kind of like dictate how our application works. However, currently it does. You can see down here at some point, you can see that we have this report out. This report out is currently how our application works. It is printing something to the screen, and that is how our INI file is outputted. I mean, the log file, yeah, it's also an output that you could reuse, but you would need to parse that log file again, which is not the point of a parser if it outputs something that you need to parse again. A parser should give you the raw data, and you, the application, in our case the main.c file, in the future the actual application that is using the library INI parser, that actually client, that customer, that main.c file, that should be the one responsible of printing it, outputting it, doing whatever it should do with it. And that is what we want to archive today. So how are we going to do this? Well, if you're taking a look at our INI parser.c again, you can see that kind of like our build artifact, or the artifact, so the output of our parser, are these three values: the current section, the current key, and the current value. These are our artifacts in question, and currently you can see that we are printing them out. How could we factor this out of that parsing function? Well, we could write a function called INI parser print, and this INI parser print would get three const char pointers. First one would be called current section, the second one current key, and the last one current value. And basically the print function would get these three const char pointers, and it would then printf them. Why is it important to factor this out? Well, if we just want to print it like that, no point in doing it. However, what we want to do in the future is we want to be able to specify a custom function that shall be executed on these three. And to be able to do this, we need to know what that is. And these are three const char pointers that we want to process. And now we are getting to something called function pointers. A function pointer is a pointer to a function. As I told you, if the application gets compiled, it's also stored somewhere in memory. So actually every function that you write, that the library provides, every function in the earth that you're calling, has an address in memory. And what this allows us is to actually pass this address of functions around with a function pointer. So basically what we're going to do is we're going to tell, hey, give me some function that takes three const char pointers and returns nothing. And we don't care what the implementation of the function is. We just need the address, and we just need to know how the function looks. So we kind of like need to know the signature. Signature is that thing. Expect the name. Okay, the name is kind of like the signature, but the main signature is void const char pointer, const char pointer. And what we basically want to have is we want to have the signature of that function that is going to process our INI. So we are going to have a function that is going to be called for every build artifact, for every parse artifact of our INI parser. And if we have that address of the function, we can just invoke it. Now, how are we going to do this? Well, we need to take a look at function pointers. Function pointer, told you that, very simple, just the address of a function. But how do we tell the C language that we want to have a function pointer? Now, the function pointer has the most ugliest syntax in the world, but you're going to get used to that if you are using it. How does a function pointer look? Well, first of all, you're going to write the return value, void. That is the return value. Then you're going to open up a bracket, type the pointer symbol, and the name. Just going to call this callback, because this is going to be called back as soon as we finished one value reading. That's why we like to call them callbacks. Now, only thing left missing are the arguments. So void return value, pointer, it's a function pointer, name of the variable, callback, and now instead of here, we have the arguments. Currently, this is empty. It's valid. We can have a void function that takes no arguments. So this is a valid function pointer. However, we want to have some parameters in. We want to have a const char pointer. Now, normally, if you would write a function, you would think that we are now getting a name for that variable. However, we don't need a name because we don't care about the name, right? This is just the type that the function is accepting. The user can name it however they like. But what you can actually do is you can give it a name so that the user knows what is meant to be there. So section key value. And we are set. We have a function pointer in here. Now, if I would copy this over, let's copy that one. It's a rather big expression, but we're going to get to it, how we do it good practice in a second. If you are taking that one and you go to your main, not main file, ini-parser.c file, scroll a bit up to that function here, there we are, paste this in here, you can now use the callback. How can we use it? There it is, callback, copy the name, or you could just also write it out. And now, instead of printing this with printf, we are just gonna invoke our callback. Now basically what we can do is we can take this variable and use it as a function because it's a function pointer. And as you can see, if I would go in here, press Ctrl Tab, you can see it's a void pointer, const char pointer, section, const char pointer key, const char pointer value, and get information about this. You can call it as simple as calling a function. Now, only thing left to do is to also add this to my parse ini from file. And now you can see that we are at something that I personally really hate. I hate duplicating code. We already have written this twice, which is okay if it is just in one function call. Yeah, go for it. Just write it out there. But as soon as you have something on functions twice, if you're having it in two functions, so you're writing it more than two times, or in general writing it more than one time. Actually, if you're writing it something more than one time, you should try to fix it. And how are we going to fix that? Well, we're going to define a new type. We already talked about type def if we had struct. So we had this like type def struct lel that basically allowed us to use the that struct with just the word lel. And what we can also do is we can type def a function pointer. So normally type def would first get the old type and then the new type. So myInt. And now myInt would be a type. And this is also how function pointers work, but they work a bit different. So basically a function pointer can just be type defed by getting this full expression in here. If we take that one in here, that callback one, and paste it in here, we would now have this defined as a type callback. I'm just going to rename this to ini underscore callback, same pattern that we had here. First our library name underscore type name, so type name, function name. Should always do this like that. Also, if you're having a struct here, you should also call it ini underscore. So this line here, that line 9, is defining a type ini callback to the exact function pointer type that we want to use. And now it's just a matter of doing it like that. Now you can just use the word ini callback with the name of that function, or that variable in this case, parameter, to specify it in here. Now to have it up here as well, callback, as simple as that. Very shorthanded, very flexible, very simple. Now inside of ini-parser.c we of course need to change this as well. So let's remove everything on the left. I'm lazy, so I'm going to keep it here. Remove these all, and you can see you have a nice clean looking signature. Callback, callback. Scroll down there, gonna see that it still works. Callback, Still looking like that. It looks a bit different if I hover over that. If I control press in here, you can actually see that it's now getting a correct name. So void, ini callback, const char pointer section, const char pointer key, const char pointer value. It's looking a bit nicer, even though like this ini callback isn't the function, but you can see it's nicely defined in here. Now, only thing left to do is to add it above here as well. Callback. And we of course also need to pass it on here so that we are correctly invoking it as well. Now, these changes now allow us to have the full functionality of printing out inside of our main function. And actually we need to have it here. You can see, if I have it like that, it's not going to work. I need to write a function for that. So let me write it. Void ini, I just could call it ini data ready here. Const char pointer section, const char pointer key, const char pointer value, and then I'm going to have a body that is going to be implemented in a second. And now the only thing left to do that you need to do is put that function in here. You can directly put that function in here. It's yellow, it's a function. Can put this function into this function, and this is automatically giving you a function pointer. You can also put the ampersand here to get an address of that function, because the function is normally already invocable, and this is kind of like explicitly telling you it is an address, it is a function. But you can also not have it in here. I mean, this looks kind of like it is a variable, especially if you don't have the Visual Studio syntax highlighting, so the ampersand is gonna explicitly indicate, hey, it's a pointer, which could also be a variable. So really, there's no point in adding it here. It's kind of like how your company does it, how you like it, how you think it looks nice. Open to you, up to the user to decide. And now, if I would start the application, it should build, hopefully, if I haven't made anything wrong, but we are not getting an output. Surely we are not getting an output because the output now needs to happen here. So let's do a printfs, which is the safe version, which really has no point in using it, but I'm going to use it as well. I'm just going to use it here. So new line is going to be alright, but now what I want to do is I actually want to write this into the INI in the style of how it would be written in the INI file. So I want to have the section here. I want to have the key here, I want to have the equal sign, and I want to have the value. So section, key, value. And of course I want to have a new line. Let's actually do a double new line here. So a complete different format. So let's start this here. And now you would see that we have all the data that we had previously, but now formatted exactly how I like it. And I like it how I like it in my main. I don't need to change my ini parser.h, I don't need to change my ini parser.c. The only thing that needs to change is my main.c. And the thing is, the nice thing is that we are getting from that, by writing it like that, is that we have full control over that. So actually, we could write two functions of these. We could say ini data ready 1 as the first function, and we could say ini data ready 2. And in ini data.2, I can write it completely different. I can write it like we did it previously, like section, backslash, or I think we did a normal slash, but I now want to do a backslash here, key, and then I could say is, and then I could say my value. So I can have two formats available here. And I could actually let the user decide which format he want to use. Could do this, can say, for example, yeah, let's maybe add this as another argument here. An optional argument that the user can specify before we have our log file. So the log file is actually going to move to position 4, and we're going to have a optional format. And this format is going to be 1 or 2. So like that, format 1 or 2. And I actually want to default to that. I don't know, going to specify this here. Format 1 or 2, optionally in here. So now we have 4 arguments, and I'm going to check the log file path here. And now I'm going to here check the format. How can I check the format? I'm going to have a const, not a const char pointer. I'm actually going to have an ini callback, and the callback is going to be equal to the ini data ready 1. So we're going to start at the function 1. Later on, of course, we are directly passing in that here as a callback. And what I want to do is if argc equals, or not equals, equals bigger than 3, so the format has been specified, and string compare String CMP was string compare, which is now inside of the string header, so I should include this as well here, because we don't have control on how the ini parser.h changed. If I remove string from here, it shouldn't break main. That's the idea here why I'm including this again. This is also why we had stdio in here, because we use print. And now we are also using the string function, so we should always include everything that we need in the file itself or in the header to that file. So if any of our libraries change, that our application does not break. I know that in a production environment this is probably at some point going to break, but you should aim to not break it. Now what I basically want to do here now is, this is now at position, let's see, this is now at position 3. So 0 is our 0 is our exe, 1 is our actual file, 2 is our format, and 3 is going to be our log file. So that's correct. So I want to get that one, and I want to compare this to 2. And if this is compared to 2, so if this is equal 0, 0 means they are the same. So if we have enough arguments and the user specified 2, I'm going to set the callback to ini data ready 2. Now, as you can see here, if somebody specifies a wrong format, I just don't care. The wrong format basically in this case means default to 1, no format means default to 1, specifying the 2 will default to data ready 2, which is our different format. And as you can see, we have stored this here as a function pointer, and we are passing this function pointer on. And if I do it like that, it shouldn't change anything. If I press F5, it should output is still like that. But if I would go back to my console here and specify the file, let's start by 1, which was in the normal format, which is still outputting the same thing that we had, but as soon as I enter 2, we are going to get the new format that we implemented with owner /name is John Doe, owner organization is ACM Widgets Inc., database server is 192.0.2.61, database port is 143, database file is payroll.dat. So really flexible and really nice. We can specify our ini parser how we like it. We can have the format that we like, we can have multiple callbacks here, we can have any format, we could store the data, we can print the data, we can encrypt the data if we like. So what you could do is actually you could spill out encrypted data if you are using that, you could compress the data, you can really, the sky is the limit. The library, the ini parser.h, which in the next video we're going to move into a proper library, not in a header and a C file that's floating around in space. We're going to do a proper library there in a second, not in a second, in the next video. But all these functions here, they really don't specify. They don't put constraints on you what you do. You can give it a raw string, you can give it a file, you give it a callback. It doesn't matter what it's doing. It is nice. It also supports logging if you want, but just if you want. So this one is not going to put constraint on you. You can use it as flexible as you like it, and this is how your code should be. This is how good code is. Good code is flexible. A good library is flexible and can do everything. You do not want to limit the user. In this case, the user is the main.c file, and what we want to do in the next video is that we actually separate this out so that we have the library, the ini parser, in a own dedicated project than the actual user, the actual main.c. So thank you for watching. See you in the next video. Make sure to like and subscribe, and until next time, have a nice day. Bye.